Hi guys, so today we're going to go over solving a system of equations algebraically. So algebraically, you could solve a system of equations using substitution or elimination. So notice that I've listed all the steps. We're going to apply elimination in this tutorial. A system of equations just means, in this case, you have two equations, so you're solving for two variables. As you progress, not in this class though, you will have three equations and then you'll have three variables. So when you're solving for a system, you're solving for more than one variable at a time. So if we look, the problem that I've given you is set up for elimination because the first step is to make sure the equations line up. Notice the x's line up, the y's line up, the equal sign, as well as the constant. If they don't line up yet, then that's going to be step one of elimination, making sure that they line up. And then you're going to have a bit of freedom here as well. You're going to select one variable and eliminate that variable by making their coefficients the same number and opposite signs. You'll see why when we eliminate it, but you do have a bit of freedom for step two because it's up to you if you want to get rid of x or if you want to get rid of y. So in this case, we're just going to start by eliminating, I'll go with y. So I'm going to look at the coefficients of y. 2 and 3, what do they have in common? Well, I can multiply both numbers so that it can be 6. To make 2 become 6, I will multiply it by 3. But you can't just multiply 2y by 3. It has to be done to everything in the equation, including after the equal sign. I'm stressing that because that's usually the biggest mistake, is that it's not distributed after the equal sign. Um, So again, we're trying to eliminate y. We've decided on y by making the same number and opposite signs. So the nice thing about this is if you look at the coefficients for y, one is already positive and one is already negative. So I don't have to worry about making them opposite signs. They already are. I just have to make them the same number. So we've decided on 6. To make 3 become 6, I'm going to multiply by 2. So from here, I'm just going to write down what I have in the first equation if I multiply everything by 3, and that will give me 12x plus 6y equals 42. And for the second equation, if I distribute the 2, I'm going to get 14x minus 6y equals negative 16. So if I look, the reason why we want in step 2 for them to be the same number and opposite signs is because when I combine them, notice that 6 minus 6 is 0. So we've eliminated a variable, hence the term elimination, and we're going to combine whatever it is that we have. So notice nothing in front of the coefficient, meaning they're positive. So 12x plus 14x gives me 26x equals 42 plus negative 16, or 42 minus 16, would give me 26. So my goal is just to solve for the other variable, the one I didn't eliminate, which is x. So to get it by itself, I'm going to divide both sides by 26, and x will equal 1. And in algebra, not much has changed. Whenever you get the x, you're going to substitute that value of the variable that you got into one of the equations. So once you get x, you can plug it in to get y. It doesn't matter which equation you plug it into. It could be the first one, the second one, or even the modified ones. So just to keep it simple, I'm going to just choose the first one, which is 4x plus 2y equals 14. So one of the original equations. And I'm going to replace the x with 1. Everything else comes down, and notice my only variable now is y, so I'm going to solve for y. So I have 4 plus 2y equals 14. My goal is to get y by itself. It's being multiplied to 2 and added to positive 4. So I always get rid of adding and subtracting first. Subtract 4 on both sides. And I will get 2y equals 10. Divide both sides by 2. Since I'm out of room, I'm not going to write that out, but I'll get y equals to 5 when I'm done. So x equals 1, y equals 5. That means 1 comma 5, x comma y, is a solution that works for both of these equations. Now to check your work, you can always substitute the x as 1 and y as 5 into any of the equations, and it should work when you're done. Okay, guys, hope this helps.